Hi, in this video we're going to have another look at the inspector and especially how it can create the specific tabs that we have seen in the last presentation of the inspector. So I will reuse the example that we defined with the order dictionary time date morph. And if we look back at the date, we can see that the tab calendar and holding the calendar morph is actually defined if we use a tool called Finder. And since the inspector is called the GT inspector, we'll look for GT inspector in the pragmas. You can see this pragma called GT inspector presentation order. If I double click on this one, it will open the different senders of this pragma. And if I look for a date, we can see that it's called within GT inspector preview in. And if I click on this, you can see that there is the creation of a composite morph with the title calendar and using the morph calendar morph. So this is how this tab is defined there. We've got the calendar title and the calendar morph under it. So now if you look at other objects such as morph new inspect and press Command D, this time we've got a tab morph that depicts the actual morph, and you can see on the right some actions: export as PNG or delete. So we'll try to find those there by searching for morph, and you can see that we've got GT inspector morph in. And if we look into this code, we can see that we've got the same composite morph with the title and display of this image, and error handling if it can't draw the actual morph, and then the two buttons that can be found there, export as PNG and delete, that are defined underneath. And the last one we're going to look at is a compile method, and we'll look at point decrease and press Command I to inspect it. And you can see that this one has several tabs. It has the bytecode, so basically all the instruction sent to the machine, so send the instruction spurial equal, gem false, push constant. The source, so this is the actual source code of the method, the intermediate representation, and a tree or an abstract syntax tree. Those are all extremely interesting, and what we can do is, if I extend this a bit, we can go to row, open another view of the same object, go to bytecode on this one, go to source on this one, and a nice thing, if I click on, for example, this instruction push constant 0, it will highlight the corresponding piece of source code. So this is extremely nice for developers of a compiler, or if you're simply interested into how the bytecode is translated into source code and vice versa. So this is interesting, and we'll look at how it's implemented. So it's implemented under compiled code. So it's right there, and you can see that we've got the GT inspector AST that's implementing the AST tab. The bytecode tab is implemented there, the byte, header, IR, pragmas, and so. So everything is implemented there using the GT inspector presentation order. So this video was there to show you that you can find how the tabs are implemented, and that the inspector is really interesting to display a particular view of the object you defined.